2007 Dodge Ram 2500 HD with the 6.7. Issue is it has a no crank, no start. You notice the engine light is on, which tells me, you know, key on engine off. That usually the computer's being powered up, but I have noticed there's no Prindle display right there. Park, reverse, neutral, drive, low. I try to crank it. There's nothing. Nothing at all when I crank it. So I have my Autel 906 Bluetooth plugged into it. Trying to auto ID it. It usually auto IDs for me. I've been having issues auto ID lately and losing comm. I have a battery maintainer hooked up, and I have it set to 13.6 volts. And that way I don't lose comm or nothing, or that's just, you know, we don't have any anomalies with that. So we're trying to establish communication now, which is taking longer than it normally does. So I don't believe it's going to have comm, but I've done a lot of troubleshooting on this vehicle. Haven't found the problem yet. I believe it's down to either a TIPM, totally integrated power module, which the gateway module is inside of that, or it's the PCM, or it's the wire integrity between all that. So I want to kind of show you what I've done in the vehicle and on the bench for testing. And yeah, it says VIN scan failed, and it's never done that before. So let me go into history and pull up the RAM again and try to get in this way from it's saved. So we got 12.8 volts according to the scan tool anyways. It's weird because now I'm losing comm to everything, which I never had that problem a couple days ago when I was troubleshooting this. I've been looking at this vehicle for a while now, and I've been troubleshooting the TIPM, which is right here. Everything's plugged in, wires, fuses, all that. The engine module, which you're going to have to get underneath to show you. And I need to look at the wiring in between, which I need to do more checks, but I wanted to show you what I've checked so far. So let's go to auto scan. And it's just bypassing everything. It's not even picking it up. And I was trying to communicate because that center light on my VCI is blinking. That is weird because the other day it would pick up every module, and actually 10 minutes before I started filming this, I picked up every module. And what I had is just like the last few days till the last week, I had the engine computer always lost, or the TIPM always lost communication with the ECM. So this lost communication with the ECM, and the ABS module always lost communication with the ECM every single time I scanned it. And those active codes. Well, right now I have no comm, which makes no sense because I had comm 5, 10, 15 minutes ago. I had it all last week. I turned the truck off, I turned it back on, you know, 10, 15 minutes ago, then I had comm again. I had the same codes, like I said. The TIPM lost communication with the ECM, and the ABS module lost communication with the ECM. So the only addition I had to that today troubleshooting it when I started the film was the ABS and the lost communication with the TIPM, and there's some, and the instrument cluster lost communication with the TIPM. So let me try it again. Let me recycle power. And you can see I'm trying to start it here. Nothing. Nothing. No comm. That's weird. Because the other day I had comm. And another thing I was going to show you if I could get in here is when I was reading the PCM, there was no codes for the PCM. But I would unplug sensors up on the engine, which I have unplugged now, and I would unplug, you know, different pressure sensors and stuff, and I would still throw, there would be no codes. But another thing which was weird is I could never read any live data on there. And then when I read the ECU information, it said it was a 2018 model, which it's not, it's a 2007. And another thing I noticed is when I went to write or read or write the VIN, it said the VIN was incorrect. Which, now that I remember talking about this just 10-15 minutes ago, I also had a VIN mismatch for the ABS module as well. So something else is happening between when I was troubleshooting it a few days ago until right now. Alrighty, I want to show you what I'm going to do next with my schematics. I printed like, I don't know, 40, 50 pages of schematics. Different stuff I have. But, so this is the main layout. So you got your diagnostic link connector. Originally, I tried to go across pins 6 and 14 here and get a, you know, my CAN bus waveform. 2.5 volts bias voltage, CAN high going to 3.5, and 2.5 CAN low going to 1.5, but I never got it because it goes through a gateway, the TIPM and the gateway, which makes sense. So after that, I back probed on the TIPM, on the CAN C bus, and I got my good square waves. CAN B bus, I probed to, I can't remember what I got, but I remember it's a good square wave. So CAN C bus is your TCM for your DSO, your ECM for your DSO, your four-wheel drive module, whatever, front driver control module or four-wheel drive control module, whatever Mopar calls it, steering angle sensor, and your ABS. Right? So, and I had communication to every one of these modules up until like 15, 20 minutes ago. So, looking now, what I want to do is show you bus communications. So, where I was probing at, just bear with me for a sec. Gotta find right here. I was going across pins 6 and 14 on the DLC, right there. Of course, I didn't get much of a waveform until I tried to talk to the computer because it goes through a diagnostic C connector on the TIPM, right to the central gateway module. And then, this is CAN B bus. That's the other CAN bus. Not really concerned with right now. I mean, I'm probably going to be because I have no communication like I did before. But what I want to do is, right now, since we're filming, here is the PCM, CAN high, CAN low, or CAN high, CAN low. I want to go right up through the TIPM connector C6, pin 1 and 9 for CAN high, CAN low. Back probe on the TIPM and see if I got my square wave, which I did a few days ago, but I want to check it again now. So I'm going to hook the scan tool up and then check it and film it and see what we got and go on from there. Oh, one more thing. For this starter, this is the starting circuit. For the diesel, for this starter to pull over to get voltage to the battery, yeah, the TIPM controls it. So I can give it voltage right here, and of course the starter, the truck will turn over, but of course it's not going to start. And then I checked this TRS sense line, transmission range sensor, down here. I checked all this stuff, and everything checks out. There also, I forgot to mention, the ignition switch, power going into the TIPM constantly I have, and, well, I did have, I might have to check it again, and power with the key switch on I have as well. Alright, so I'm back probed on the TIPM here with everything plugged in. One lead going to the TIPM and the other lead going to battery ground with my oscilloscope. So what I'm looking at here, sorry, it's kind of windy out here. I'm on pin 1, connector C6, so CAN positive on the TIPM. Well, connector C6 is this one, third one up, which is down there. Just got to trust me, I'm on the right one. Pin 1, CAN high. I got key on engine off. Well, the engine doesn't run, so obviously key on engine off. But look, I'm using my MP408. I have an Ultra I can use too. I got that one charged, so I'm using this one. But look, my bias voltage at 2.5 volts looks good, and there's my messages going to 3.5, 3 3/4. So get some different scaling here. So that's CAN high. So now let's check CAN low and do the same test. All right, so now I'm on CAN low, which is pin 9, which is white with the light blue. Pin 9, white with the light blue. Jump probed, everything's plugged into the TIPM, and I got a good waveform. I got it playing right there. That's CAN low on the back of the TIPM. Because remember, I said I tried to scope it down here, but you're not going to get that message unless you try to communicate with the vehicle. Once in a while, I notice some anomalies in this bias voltage. Maybe not. Yeah, like, I don't know, right there, the bias voltage was jumping up a little bit. You know, 2.7. But anyways, so I'm not going to get my can high, can low down here at the DLC because there's no, it's got to go through the gateway, obviously. So, what I want to do now, while that's reading, key on engine off, I'm going to go ahead and try to communicate with it again. Now it's Bluetooth back up. Now let me try to redo that. See if it has, I don't know why it wouldn't have COM when, but this is the same results I got before as far as a can high, can low, except I would always have COM to the vehicle, which well, you've seen on film, I do not currently. But look, it just popped back up. Now I got COM again. What is going on with this thing? So I'll show you what I was going to show you earlier. We'll scan all the modules. There's the VIN. We'll do a complete auto scan here. See what the scope's looking like. Kind of wish it would lose COM again so I could see what that CAN bus looks like. Yeah, see, now it's scanning everything, but earlier it didn't do nothing. So we'll keep letting it do that. Now it may throw some erroneous codes because I did have that unplugged to back probe that and plug it back in. So we'll take a look at that, but I know what codes were always staying in there. Yeah. There's a bunch more codes than there normally is. I think this is going to end up being a pretty long video. I'm not sure yet. All right, so go to report. ABS, lost communication with ECM. I've always had that one. This one, lost communication with integrated power module. No, not always. VIN mismatch. Yeah, I remember having that one a lot. Airbag. Can B bus, probably, honestly, because we had that unplugged. Yeah, I went to store because we had that connector unplugged. Mechanical instrument cluster, we never had that before. These, or this one here, the lost COM with integrated power module. Lost COM with the radio, I don't care because it's an aftermarket radio. Well, you got all these codes in here. But anyways, what I've always had is lost the TIPM, lost COM with the ECM, and the TIPM or the ABS lost COM with the ECM. So the TIPM lost COM with the ECM and the ABS lost COM with the ECM. So what I'm going to do now is I'm going to erase everything and see what comes back. See how our scope looks. You know, once in a while, I know these kind of go high. I don't know if that's an issue or not. All right, so it's erasing the last few ones here. I'm on the side of the road here and people are driving like idiots. You would think they would move over to the side, but you know, not in this town. All right, so let's look here. So everything racy, what came back. ABS, lost COM with the ECM. That's the one that always comes back. Central gateway, fog lamp, always comes back. Open circuit, don't care. But the central gateway, lost COM with ECM, I care. The radio, I don't care. Aftermarket radio. HVAC, lost COM with the radio, don't care. And overhead electronic module, lost COM with the radio, don't care. So the ones that always come back or the loss TIPM, lost central gateway module loss comm with the ECM, and the ABS loss comm with the ECM. Let me escape out of this and rescan. See what our scope looks like. See, I have comm again, so I don't know why I didn't have comm earlier. I don't know, I was like, maybe it's a low battery issue. That's why I hooked up my battery power supply. But it's been maintaining it when I've been filming this whole time for 13.6 volts. So that's honestly the first time I lost comm on film with this vehicle for every module. But we'll rescan it here. See what we got. And then I'll show you what I did next. So I exit out, rescanned it. Well, here we go. ABS, lost comm with the ECM. This time I lost comm with the TIPM again. VIN mismatch, VIN vehicle configuration, mechanical instrument cluster, don't care about those. Central gateway, same one, lost comm with the ECM. So the only addition one is the TIPM one, ABS. So that's a concern there. Now let's try to go into the PCM. So go to the PCM. I read codes. Before it never showed any codes. No fault codes. But I clearly have this pressure sensor unplugged. The sensor for the injectors or wire harness to the injectors unplugged. A map sensor, pressure sensor in the back unplugged. Nothing, no codes. And then I go to live data and would have a no comm, or it did before anyways. See what it does now. And our voltage is 12.8, 12.9 with our battery power supply. See, no comm, no live data. Then what I did is I went to ECU information, trying to get all this on film, because this thing is kicking my butt. It says model year 2018. Well, this is a 2007. Here's the ECU part number, some data, right? So I was like, well, that ain't right. And then I went to, I think it was special function, to actually read and write the VIN, to set the VIN. You can use this function to read and write. This function only supports new ECU to write VIN. Old ECU doesn't support this. Okay, so it won't let me write the new one. Because I don't have a new VIN in, but let's see if we can read it. And it says the VIN is not valid. Press OK to modify it. Well, I won't, I mean, I can, it's this VIN. It ends in 8736. Well, you can't read it on there. You just got to trust me. It's 8736. Is this VIN right? Yes. And it won't let me write it. It's not a new computer, obviously, so maybe that's why. But it is weird that it won't. It says this selection is not supported by the ECU. It's because it's not a new ECU. But, and I've even reset the ECU and everything. Nothing. But when I go to read the VIN, to just read it, it says it's not valid. Now, this vehicle does have a tune on it. I don't know if it's from the tune that's doing this or what. See, it's not valid. But I can go to active test. I mean, I can turn the fuel pump on. I can do stuff like that. So, what I'm going to do now is I'm going to go to generic OBD and show you some information in there, what I've noticed. Once this thing backs out, go to this one. Can you grab it, buddy? Papers are blowing around. Evan's helping, right, buddy? You don't want to be on film? Auto scan. Go ahead, you can ride it again. While that's scanning, he's got to ride his four-wheeler. All he wants to do is ride four-wheeler and dirt bikes. So we're going to do the global EOBD and see what we come up with. Just generic OBD, not the modified enhanced data. DTC is going to show no codes, even though we got stuff unplugged. You know, engine lights on, no Prendo switch, no fault codes. When I go to live data, it read live data before, but it wasn't much and it was very distorted data. Yeah, look, only this much. But engine coolant temp, negative 2.2 degrees. Well, it's like 65, 70 degrees out here. So, I don't know what's going on. You know, that's processed data, I'm sure. So I noticed all that. I took that for a note. And what I'm going to do now is I'm going to unplug this connector and probe it right off of this TIPA module. And then check the CAN bus there. And that's where I noticed some anomalies. I'm not saying that's right or wrong, but I want to show you that on video as well. All right, so I got my AS wave kit out, some leads I've made. What I'm going to do now is I got the TIPM connector unplugged, and I'm going to pin 9 right off the TIPM with the connector unplugged, right? So I got power and grounds, turning the TIPM on. Pin 9 is CAN bus, C bus negative, right? Now, there's a 120 ohm termination resistor in this guy. The other one's in the ECM. So right now I only got 120 ohms on this bus, which I'll change that in a second to get to 60 ohms that were required. Oh, and by the way, across pins 6 and 14 down here, I do have 60 ohms across the bus. Well, if you look, let me turn the key on, engine off. This waveform here is looking, I would expect to see a square waveform. So I put a trigger on here. I don't see a square waveform. It's very distorted. It's a lot of hash. Maybe it's signal reflection, right? Doesn't look right at all to me. I mean, you can see your 2.5 bias voltages right there. So now I'm going to put a resistor in there and make it 60 ohms across the bus and do the same checks. All right, so now I got 2 wires from my breakout leads going across CAN high and CAN low. I have a 120 ohm resistor in there in parallel, just like the one in there, and I measure 60 ohms across the bus. If you measure from here to here, you get 60 ohms. You just got to trust me on this one. I've already checked it at 60 ohms across the bus. Key on, engine off, and I still get that same distorted waveform. So now, let me check the other pin. I'm trying to film and do this. I'll just put a damn hole in my hand. Same thing. So that's CAN high, right? Because there's your 2.5 volts going high. But it looks very distorted, even though we got the right resistance across the bus. So I was like, maybe it's a bad TIPM. Let's go back to the other one. Just to see. I have to set my phone down to do that. So now I'm back on the other one. And there's your CAN low, 2.5 volts going down. But it's very distorted. So I'm like, I would think I would see a square wave. I'm on DC, but I'm still not seeing a square wave. It almost looks like an AC signal, even though I'm on DC. So I was like, well, maybe it is a bad TIPM. I know there are supposedly common issues on these trucks. I'm not sure exactly. So just so you know, I did the same exact checks on the bench. I may do in this video, but probably not because it's going to get pretty long. I took this whole TIPM out. I powered it up on my bench with my breakout box. So I powered it up on my bench with this Go Diag breakout box. I powered everything up, power and grounds, put the schematics, and put the 60 ohm resistor across the bus. Or actually still 120 across here because it's the other 120 is in the TIPM. So I got 60. And I got the same exact results with that distorted waveform. All right, so the distorted waveform I'm talking about obviously is this one. So I may show that on video, taking it out of the actual vehicle, but I may not. Depends how much time I have, but just got to trust me, I got the same results on the bench. So then what I did is I took the engine computer off of the truck, which is down. Trying to get under here. That's the engine computer. I took that engine computer off of the vehicle, powered it up on the bench, and did some tests that way, which I'll probably show you that on video. This may be, I don't know if it's going to be a 1 part, 2 part, 3 part, 4 part. I don't know how many part video it's going to be. Just depends how this troubleshooting goes. But what I'm going to do next is I'm going to take this PCM or ECM off of the truck, do a bench check on it, and power it up. And I got weird looking bifold to do weird looking waveform. But I got the same results as far as I could have. I had no codes, and I couldn't read any live data, enhanced live data. So, but I had no codes. So I'm going to do the same check on the bench, and then after that, I'm going to check, load test the power and ground wires going to this guy and make sure that wire is good. So if the wire does not load test good, the wire integrity, must have a wiring issue to the computer, which would make sense. But if that checks good, and it's not the TIPM, then it's down to the TIPM in the PCM. It's got to be wiring, TIPM, or PCM. So next check is pull this computer back off the truck and do some bench checks. All right, so I got the ECM on the bench. This is connector 2, 6.7. I got all the pins laid out, all the sheets, or all the pinouts. So what I got going on here is just to show you, I still got to hook some more wires up to my breakout box. It gets voltage from the house, and then it converts it to 12 volts, or 12.6 DC. You can hook a scan tool up to it, and I got all my breakout leads. So these 3 powers here, there's 4 powers, but these 3 are spliced into this, which is hot at all times, right? It's a 30 amp fuse, right? So am I getting enough amperage from this machine? I was talking to a guy, met on Facebook. He's got a very good point with that. So I'm going to do this test, and I have to do some other tests from that. So what I want to do now is, well, these 3 wires right here are those pins, which are 49, 50, and 60. I got those going to, they're all say 12 volt 30, so that's that switch right there. Main power onto this. I can turn power onto those 3 wires, which are these 3 right here. The other wire, pin 45, is a 10 amp fuse. I have that one going to my 12 volts 15, which is ignition. So I'll have main power come on for this box, main battery power, and ignition. So when you turn the main power on to this computer, that'll be these 3 wires, and then this one will be ignition. And now I got to hook up these 3 grounds, which are pin 47, 48, and 57, all spliced to the ground. So we're going to hook those up next. All right, so I got my 3 grounds hooked up, power and ground to the module. Now what I want to do is I want to hook up, I'm going to hook off the ECM connector 2, pin 1 and 21, 1 CAN C bus high, 21 CAN C bus negative, 21 CAN C bus negative, 1 CAN C bus positive. I'm going to hook those up to pins 6 and 14 right on here. That way I can communicate with my scan tool. On here, on the truck, it goes to the TIPM, the central gateway, so it's going through a different, part of the module, but I want to be able to communicate with it. So I'm going to hook those 2 wires up, and we'll go from there. All right, so pin 1 is CAN high, C bus, which is going to my pin right here, says CAN high, which goes to pin 6 on the DLC. Pin 21 is CAN C bus negative, which is CAN low, goes to pin 14 on my breakout box. So there's 1 and 21. So now I'll be able to power this thing on and communicate with it. So what I'm going to do is I'm going to hit the main power. That just powers the board up. Oh, one other thing before I do this. There's a 120 ohm termination resistor in this ECM. There's another 120 ohm termination resistor in the tip-em. So right now I got 120 across this. So if I read right now, I'll get 120 across this. So let me show you that real quick, and then we'll put our other termination resistor in there. Alrighty, so here's my can high, can low. This is connector 2. Everything's on connector 2. I had these over here earlier for can high, can low. That's not right. It's over here. So everything's hooked up right. Pin 1 and 21, I believe. Yeah, 1 and 21, can high, can low, which I have hooked up for can high, can low. Everything off. I got 120 ohms across the bus, right? So now I'm going to put a resistor in there, another 120 in parallel across it, so I get 60, and we'll attempt to communicate with this module. All right, so I put another 120 ohm resistor across the bus, so this would represent the termination resistor in the tip-em. This one is in, the other one's in the ECM, and now we got our 60 ohms across the bus. So we're going to hook up the scan tool and communicate and see what our results are. All right, so I got my VCI plugged in, going to the program. We're Bluetoothed up. And then, once this program loads, well, we got to turn power on to everything too. So now the computer's powered up, Bluetoothed up to the scan tool. We're going to go in there and do some diagnostics on the bench. I don't know if you can read that voltage, 12.5 it looks like. You can see pins 6 and 14 communicating, flashing, once we establish communication. And up here it says we got 12.1 volts. So I'm going to go into diagnosis, control unit, powertrain, engine, because that's the only thing we're going to have communication with. You can see it communicating, the center light's flashing. Those two, I don't know if you can see it in the film or not, 6 and 14 are strobing. Boom, we're in. So let's read codes. We should have codes because everything's unhooked. No fault codes. Just like on the truck, we'll go to live data. And let's see what we got in here. It's going to be a no-com, just like on the truck. Which, I don't know, is it because of a tune? It shouldn't be because of a tune. There's something going on. Yeah, no-com. So you can do the same stuff, like you go to special function. It's just like it's on the vehicle. We just got no other sensors hooked up, right? So let's do a couple other checks here since we're here. Let's go, not reset the ECU. I mean, I've done that, but it hasn't done nothing. It doesn't do anything. Let's try to read the VIN. Same exact thing. Not valid. Okay. So let's go to Ecu Information. It's going to be the same exact thing. (2018) when it's a 2007 model. Now on the bench, to try to communicate with global OBD, I'd have to change this pin around to go to the diagnostic port and change some stuff. So I'm not going to do that. But we're using the factory. I mean, we're using this Chrysler Dodge software, right? And it's getting the same results we got on the vehicle, off the vehicle. But now what I'm going to do when I'm communicating, I'm going to hook up my oscilloscope, because on can high, can low, we should have a good known square wave. So let's do that next. Alrighty, still powered up, still 60 ohms across the bus. I got my oscilloscope hooked up, and we're got a ground here, and we got a signal coming on pin 14 for can low. Well, if you look here, I'm on a 1 second scale. I'll put it to 2 milliseconds. And look at it, it's not right at all. There was some communication there, but you're 2.5 volts, pause this, is right down the center. But what is all this hash? Should have a nice square wave. Well, if I go into, say, my diagnostics and go to ECU Information, so I'm forcing it to talk, it looks all distorted. Let's go into active test and do the same thing. Okay, let's go into read codes and do the same thing. Because once in a while I'll see like a message right there. See that? Back up. That's can low. Boom. Now let's do can high. I'm going to move this to the other pin. It's on can high, so we're going to hit play. Again, distorted message. I think it is anyways. So let's go back and read codes again. But either way, with this thing power ground, it should be a nice square wave. Like we showed earlier in this video there, right there. Right? We should have a nice square wave. This hash shouldn't be, and there should be a bunch of square waves when we're communicating. This tells me there's a bunch of hash. Maybe that's why the TIPM is not communicating with the ECM, and the ABS module is not communicating with the ECM. Maybe it is an actual ECM issue. But you zoom in, you can see your square wave in there, but right? But you got all this hash on the bias voltage. There's your bias voltage, 2.5, 2.6. I just moved it around a little bit, but you can see that it's, you know, yeah, 2.6 bias voltage, roughly 2.5. So, but look at all that noise, right? So why is that? Why is all that hash in there? Put a trigger on there. Why is all that hash in there when normally when I power other modules up on a bench, power and grounds, get the right bus resistance, termination resistance, which we have, you have a nice can high going from 2.5 to 3.5 and can low going from 2.5 to 1.5. I don't know what all this is, but maybe that's, you know, the issue. So now, like I was talking to a guy, but he was in Canada, I believe, and he's got some good points. I've been talking to him on Facebook. He was saying, well, maybe, you know, maybe there's not enough. It's not, you know, I got to do some more checks, right? Like wire integrity checks. Maybe it's not handling the load. Maybe this thing's not putting out enough power on the bench. And maybe on the vehicle out there, maybe it's, what you can't tell, it's out on the street. But maybe the vehicle out there is not putting enough power because there's wires broken or something, and stimulated in here by this is not getting enough power. Maybe it is. Maybe it's a bad TIPM. Maybe it's a bad ECM. We're going to have to do some more checks, obviously. So we can, I think the next step is to, you know, load test basically the power and grounds where these wires go into the vehicle and make sure they load test good, power and grounds. Or we can hook up a power supply to this and do the same thing, check the computer bench on the bench in here, as well as do it on the vehicle, the load check. And if we find something, okay, there's our problem. But if we don't, then is it in the ECM again or the TIPM? That's why I was looking at the TIPM earlier, because I had a weird waveform. But maybe it's supposed to look like that, you know. And then, but I got a really weird waveform on here, and I can't communicate with live data and stuff. So it's looking like an ECM, but not 100% sure yet. So we got to do some more troubleshooting and go from there. All right, so I got a car battery hooked up, power and ground. I got my powers going to this, ground's going to this. Nothing's arced out against the case. And what I'm going to do here, I have my oscilloscope playing, trying to film this at the same time. Let me get my leads hooked up and I'll come back. All right, I'm back. So, power from the car battery, ground from the car battery, oscilloscope ground, scope's playing. I'm going to probe this one. This is can high. I'm just going to barely touch the pin. And you can see it there. I'm going to let go. Goes away. I'm going to touch the pin. So the computer's powered on. You see the 2.5 volts square bias voltage, but there's a lot of noise in there. I'm going to go to the other pin, can low. There's can low. There's can high. There's can low. There's can high. So if I stop in and zoom on it, that's what it looks like. Far back, right there. There's your square wave. going from 2.5 is your bias voltage, going up to 3.8, 2.5, 3.5, 3.75. Yeah, so that's good. God, I wonder if it is a power and ground issue, like that guy in Canada said. I wonder if he is correct. So let's check it again. And I'm just using a car battery, you know, because like the guy told me, he's got a good point. It draws 30 amps on the one circuit. It has 3 wires. The other one's up to 10 amps. Up to 30 and up to 10. Doesn't mean it's drawing that, but. So, if what am I doing here? I got a probe can. This one, just touch it. I gotta hit play. If I just touch it, there's can high. And then there's can low. Let's switch the scaling around to like a 2 millisecond division. That's a lot of traffic in there though. I don't know, maybe this ain't the issue, but maybe it is. Let's go to like let's scale there. Yeah, there's still some hash in there. Yeah, like all that hash right there. I mean, the waveform does look better, but let me check it again. There's can low. Stop it. Let's zoom in, and we can try to communicate with the scan tool as well and see if anything changes. Yeah, so there's our square wave. Then you zoom in farther, then you get that hash, which I've never seen that before, so I'm not expecting that. So what I'm gonna do now is I'm gonna hook up my power supply. It's just a better clips. It ain't gonna hurt nothing because power supply, this can handle up to 100 amps. It's only gonna draw what it needs, but this can go up to 100 amps. I'll set it to, you know, alternator voltage. I'll set it to like 13.6, 13.7, and we'll do the same checks. Alrighty, power supply is hooked up. Set to 13.7 volts DC. Like I said, that can handle up to 100 amps, so this should be plenty good. Powers, and it's nice because I can get all the little teeth, or all the little blades in one tooth, so it's all nice and tight for power and ground. Old scope lead on the negative there. Scope playing. Let's go to can high, just touching it right here. There we go, touching it. There's can high. There's can low. There's can high. Let's zoom in and do the same check. See where we're at. And we got a good power supply. So if you go, you got your bias voltage of 2.5 and 3.8 to the peak. Keep zooming in, but I'm still get that hash, right? So now let's go to the other pin, can low. There's can low. Same thing, stop. Come on. Zoom in. Your bias voltage is 2.5, going down to 1.2. But you zoom in, you still get that hash. So that does not look right to me. But it does look better, right? Now what we're going to do is I'm going to try to communicate with this with it powered up through the breakout box. Alright, so I'm still using a power supply. I got the breakout box. The only thing I'm using the breakout box for now is my can high, can low lines going down through these two pins, and I got power and stuff, and I need to hook up my VLC, but I'm probing there for can high. There's can high. It looks very, you know, very, very messy, right? But if you look, 2.5, 2.6 bias, 3.5 there. Now let's move it to the can low one. I don't know if we're going to get much, if we're going to get anomalies, because we're not using this as the power as well. Shouldn't matter, but we got so many variables. Well, not too many variables. This should actually be just fine, because we're just powering it on when we power the deep VLC up, or VCI up. So this is can low. I mean, because I'm zoomed in so far in the scaling. Yeah, just a lot of noise. But if I stop it, yeah, it just looks like complete crap. Do that again. You know, my connections might not be the best. Maybe put a low pass filter in there. Let's freeze it there. Well, there it's good, or better. And you go forward, it gets real hashy. But let's check there. Bias voltage. I'm in the wrong spot. Bias voltage, we're going can low 2.5, going down to 1.4. So now let's plug the VCI in and check communication. You know, actually, we're not going to have good communication. We're not going to have any communication right now because I'm trying to communicate with the VCI plugged in, and I have a no-com. Well, I believe why is because the only thing we're using this breakout box for now is can high, can low. But we're getting a power and ground from the power supply, but I would imagine you would need a good, this thing has to be grounded for that dongle to read through this breakout box through the ECU, and I believe that's why we have no COM right now. So that's what I wish you would. I'd have to think some more. That might be a different part of the video, or another part I do. But I believe that's why we have no COM right now. It's because we're only using this can high, can low, but our power and grounds are coming from a different source, not the same source that we're plugged into the dongle with. So that's going to change it. Because I wanted to do that to see if we had, you know, actual live data and actual codes and stuff, because we do get some different results. But what that tells me now is I need to go onto the vehicle and check the power and grounds going to this connector and load test them and see if there's an actual issue with that, and that would make sense. Or, you know, is it a wiring integrity issue, or is it the ECM issue, or is it the issue with the TIPM, you know, the gateway module inside of it. So that's probably going to be it for this video. We'll call this part 1. More to come on part 2, and then we'll keep troubleshooting and go from there. Alright, I said I was going to be done, but so for me to get COM with a separate power supply to my scan through the VCI, what I did is I took a jumper lead from this breakout box ground, and I went to right from the ground from the power supply ground, you know, to the breakout box, and now I have COM. So if I go in the ECM, you can see it's starting to communicate. The center light flashes. Now I have COM with an external power supply. So now we're using an external power supply, you know, up to 100 amps. It's not going to take that, but you know, we have that, and we're not fused, but we'll be fine. And then we're checking it that way. So now let's read codes, see if we get the same or different results. Same results, no fault codes. See if you got live data. God, I thought we were on to something there. Maybe this proves the ECM is bad. Yeah. See, it's communicating, it's strobing. We got full, you know, we got how much amperage this thing is drawn. So this will at least kind of eliminate some wiring issues on the vehicle. No COM. Again, so we're getting the same results, even though we got a good power supply to this. I mean, I'll still load test the wires on the vehicle, but I think this kind of, you know, is another way to check it. So let me check that again while I'm doing it live here. No fault codes. Go to live data. It's kind of needs to focus. And we're going to have a no COM for live data. But that bus waveform, I mean, it looks better with good power. But it looks better, but it looks very distorted too. So, no COM. So let's go to special function to read the VIN. It's going to probably say the same thing, I would imagine. So now it sounds, to me, it's down between a bad ECM or a tip 'em. Well, I mean, I think ECM personally, we got anomaly results with different factors, and it's got a tune on it and stuff. But then the tip 'em, it's got some different waveforms too, so more to come. But let's go to set VIN and see what it shows to read it. I would imagine it's going to say nothing, or you can't read it. It's not valid. I mean, it's not going to even let us write it because it's not a new ECU. And I don't know if that's because of the tune or not. So let's go to ECU Information and see what it says. Same thing, 2018. It's not going to change anything. So our waveform, though, one last check. My camera is about to die. Let's probe it in can high. But there's our waveform. I freeze it. I zoom in. Looks pretty good, square, but till you really zoom in, you see all that noise in there. That's not right to me. I think that's what the issue with our possibly our ECM is. So I believe it's down to a bad ECM or tip 'em. More to come. I'll do some more troubleshooting, but that'll be it for part 1 for this 2007 Dodge 2500 heavy duty with the 6.7 diesel.